Thank you all for coming. So my name's Tyler. I'm a software engineer at Snowflake. I've been there 4.5 years, and historically worked on a lot of data pipeline stuff, but recently have kind of started helping out in some of our Iceberg and Polaris efforts, primarily in the open source side of the world. In a past life, I did a lot of work with Apache Beam, and so kind of have a lot of experience in the Apache realm from there. And so as Snowflake has been trying to move pretty quickly into being a more active participant in open source, both from contributions within projects like Iceberg, as well as with Polaris, which we're taking to open source here in the next few weeks. There's been a lot of interest in moving forward, so I've kind of gotten involved in that. So that's how I got pulled into this. Today, I'm going to talk about a proposal that we have brought to the Iceberg community, and which is we're actively working through, which is variant support. So, quick show of hands, how many of you know what the heck I mean by variant support when I say variant? Okay, like maybe a third. Great, that's fine. So our agenda, I'll cover what variant is. I'll cover it at a high level, then I'll kind of walk through a short little example as well. Then I'm going to talk about the process that we're going through in Iceberg. I mean, this is for any of you that have done open source stuff, this will be nothing new whatsoever, but just for context. And then I'll spend a little bit of time kind of talking in detail about the pieces of the proposal. I'm not going to go super in depth. There'll be references to the active discussion as well as some of the sources online if you want to go dive in deeper. And I said I'll have references, but that's a lie. I didn't do the references slide, so sorry, but there are references sprinkled throughout. So with that, let's get going here. So what is variant? So a variant is a data type. So this is effectively, if you're thinking of a table like a Snowflake table, or just any Iceberg table, this is Iceberg, I should say Iceberg. It is a column type, a data type, that is for semi-structured data. So when I say semi-structured data, what do I mean by that? I think the easiest way to think of it is think of JSON. JSON is, a chunk of JSON is semi-structured data. Semi-structured because if you know JSON, like it has a structure, right? It's got this hierarchical structure with named fields. It has arrays. It sort of has types. JSON's a bad example here because the typing in JSON is kind of weak. It's kind of got like numbers and strings-ish. But that gives you a sense for it. Like there's structure to it, but it's not strict. Like you can have one JSON blob that has like, a couple fields, and then you could have another JSON blob that has just deep, ridiculous nesting. And one of them could be all strings, one could be a mix of things. And so it's like there's some amount of structure, nesting, arrays, fields, and things like that. There's some amount of typing, but it's not consistent. It's not like a SQL table where you've got, I've got 20 columns and like each of them has a type, and maybe you support null and things like that. But basically, like it's pretty strictly structured. So semi-structured data kind of falls in this very dynamic range. And the use cases for it, just to kind of give a little more context, JSON data is a great example, or even things like Avro or Protobuf, where like those have a little bit more of a strict structure to them, but you've got all these optional fields. So at the end of the day, when you've got a whole bunch of protobufs, you've got a lot of sparseness in the data. Another example that we use within Snowflake a lot is people just have piles of Parquet files that have been created, and they don't know what the schemas are. They aren't even necessarily consistent. You're just like, I don't know what this stuff is. Let's go explore it and figure it out. You can just import all that stuff into Snowflake as variant. And so for basically, you get like for each file, you get a single column that ends up looking kind of like a JSON blob. And so you've got this, because as I'll talk about later, it's self-describing, you get the structure out of it when you query it, but you don't have to have consistent structure. And so it allows you to kind of explore data like that. So those are kind of the use cases. So variant as a data type brings three things to Iceberg. One is the binary encoding of this semi-structured data. So it's a way for you to encode it such that it can be written and read back. But if you just do that, it turns out that it's not super efficient. Like if you think of just like trying to query JSON data, because there's a lot of parsing involved, kind of traversing to get down into the various pieces, if you want to run efficient queries over this stuff, you're going to have a bad time. And so really to have variant be performant, there's kind of two things you need to bring to the table. One is enhanced metadata for pruning. So if you think about how these columnar analytical engines work, you give them a SQL query, they look at it and they see, okay, well, you're like looking at these 2 fields out of a 50 field table. A, I'm not even gonna worry about any of the rest of them. We won't even read that data to begin with. B, I have all these stats about all the various files of kind of what min and max values are within the files. And I know, you've said, well, I want things where timestamp was between, yesterday and today. I can cut out like 98% of the files and not look at them, right? So pruning is super important for getting good performance. When you've got these semi-structured blobs of JSON data, if you don't have stats on the various like sub pieces of it, the subfields, you just have to scan everything and filter. And so it's very expensive. And so enhanced metadata for pruning basically means you parse and look at the data that's in there and you pull out stats. And so you create stats for all the various sub pieces of this, JSON-like structure. So you've got A.B.C. For A.B.C, the min is 10 and the max is 70 for this specific file. And so that lets the system that knows how to read this stuff prune things efficiently. And then the second piece is materialization of subcolumns. So even if you have good pruning, you still can have these giant blobs that you have to jump into and parse out the pieces. In a lot of cases, you can end up with technically semi-structured data that in a lot of cases is actually fairly regular. You always have A.B.C and it's always an integer. And so in those cases, if this is something that shows up a lot and you might want to query it a lot, it's actually more efficient to go through and pull out the A.B.C field into a separate column, materialize it as though it's a proper column in your columnar data. And then if you actually just query A.B.C, you don't have to go through and parse that stuff out. You've just got it all already materialized like a normal integer column. And so that's kind of the third piece of it. And so all these together give you a very dynamic but very performant way to query the semi-structured data. And so that's what we're bringing to Iceberg is a proposal for kind of all 3 of these. And I'll talk through a little bit more of what each of them looks like. I kind of already talked through an example trying to give context, but I'll walk you through this at least. This is a little bit detailed for slides, but I didn't have much time, and so I grabbed this out of the proposal. So this is directly out of the Iceberg proposal. So this is just showing, like, if you wanted to create a table, this is using sort of Snowflake's variant implementation. Create a replace table with a single column that is a variant. And then you can go in and insert into it basically a JSON blob that has, as you can see, this is kind of what I meant by semi-structured. Like, it clearly has a structure, right? But it's a dynamic structure that we've just described here. There's a date, there's a dealership string, there's a salesperson that's kind of an inner object that has an ID and a name. Then you've got a couple customer names, and then you've got a description of the vehicle, which itself is like an object that has make, model, year, price, extras. Extras is an array. You've got an array of various features on it. So like there's a lot of interesting data here, and there's clearly a structure, but it's just kind of thrown together as a JSON blob. So you could insert this into this table. It would be a single row, a single value in a single column in a single row. And then if you want to go to query it, you can do things like, I want to pull out the dealership. I want to project out, the customer name and the vehicle, and I want to filter on, customer name being, Joyce. I'm going to let Jonathan figure that out. And so what you get then, is you get back the row and you get back the pieces, and it's like you're querying a structured data table. But you've kind of pulled this all out of that unstructured piece. All right, so now before I dive into more details on the encoding and the metadata and the materialization, I'll talk briefly about the whole process here for Iceberg. So again, for any of you who've done Apache work in particular, this will not be surprising, but there's basically 3 steps to getting something into an Apache effort. One is you take a proposal to the dev list. The dev list is this mailing list. For Apache projects, like the dev list is, anything that happens in the project happens on the dev list. If you take stuff to a meetup and discuss things, you go meeting on, on Zoom or Meet or whatever, that's fine. Doesn't count for anything unless it actually is on the dev list. And so the way you start off is you take a proposal to the dev list and people provide comments. And so we actually started out basically just saying, hey, we want to do variant. We don't have a proposal written up, or folks open to the idea, got positive feedback on that, a little bit of feedback on how to shape the proposal. went back, wrote up a doc, a Google Doc, and then shared that to the list later. Since then, we've been iterating on, so that's gotten us to here. So we're now at part 2, sort of. I'll explain that in a little bit, but the sort of part. But at this point, we're discussing, what does the proposal look like? What should we have in it? I'll give a few more details about sort of the stuff going on there. Eventually, the goal is to get to then consensus, where everyone's kind of like, okay, the shape of this is about what we want. We're happy. Usually it ends in a vote, but usually with Apache at least, the votes are intended to be kind of just sort of a formality. Like everyone knows everyone's on the same page. You do a vote and no one objects. That's sort of the intent. It's not a like, oh, let's keep voting until we get this thing through sort of a thing. And I say we're sort of here because we started with encoding. Remember, we had the 3 pieces: encoding, metadata, and materialization. We started with encoding pulled out separately. That one's getting very close to consensus, I think. I think we'll get there relatively soon. We need to make a little more progress on the other 2. So now, let's see how much time I have. I need to go faster. I'm going to talk a little bit about these various pieces. So encoding-wise, basically what we're capturing is, you can encode. Remember I talked about JSON. JSON's got all this structure and it's got kind of this weak type system. Imagine JSON with a better type system in it. That's kind of what it is. You've got objects with key value pairs, you've got arrays, and then you've got scalar types. It's pretty much whatever you'd expect to be in a database. For Iceberg, we're going to end up with all of the Iceberg types. I guess what we have proposed actually to Iceberg is that we simply adopt the variant format that is actually in Spark currently. So Spark came out with their own variant implementation earlier this year, I think it was. So Snowflake has had a variant for a long time internally. We've sort of hemmed and hawed about open sourcing it. We'd originally thought we would just take our variant to the proposal, but we noticed that Spark had put one out, and we started looking at it. And really, like semantically, they're basically equivalent. They're not byte equivalent. So I'll talk you a little bit through kind of what the encoding looks like, just to give you a sense of it. And I'm going to elide a bunch of stuff. This is all taken from. I assume the slides will be made available. This is just taken from the README in Spark on their variant. But basically, you can think of a variant as essentially a metadata portion that describes various things about, primarily is giving you, the metadata portion describes the kind of the dictionary encoding of all names. So it's got kind of a header that tells you the version. Some things about the offset size thing is then used to actually describe, the header's followed by the dictionary section. So it tells you the size of the dictionary and then offsets into the dictionary, telling you, each of the entries in the dictionary, here's where you find the next string effectively. And then it's followed by the actual strings that are in the dictionary. And then for a given value, each value looks roughly like this. It's got a couple bits that describe the basic type. There's 4 basic types. You've got primitives, you've got short strings, you've got objects, and you've got arrays. Each of those basic types has their own specific header. Like for strings, the header is just the length of the string, and then it's followed by the value data, which is the string data. For objects and arrays, like that, the value header is more complex. And so what you end up with is you basically got this metadata section that gives you the dictionary of the field names that can be in there, and then you've just got, no, go ahead. Yeah, and then you've got basically just a list of all these values after that. These are all the various encodings, the primitive type encodings that are supported by Spark. No UUID. I think there's a couple other ones that are missing, but you can see basically they're all efficiently encoded, right? And this allows you to capture, you can kind of scale your ints down to, if you've got small numbers, you can use an int 8, you can use 8 bits, you can go up to int 64, it's got the decimal, so it's intended to be a compact representation that, efficiently encodes data in really sort of, native sorts of ways without using as little space as possible. So before I jump into metadata, so that's kind of it on encoding. And I think the other interesting points to call out regarding this proposal in Iceberg is, we came and basically said, we want to do the Spark thing. Let's do the Spark thing. And there were a lot of comments of like, Well, there's other options here that you should consider. There's BSON. There is, I'm of course blanking because I'm giving a presentation, but there's, like Amazon has a thing that they've made that Ion. Amazon has Ion that does similar things. And so, maybe we should consider those. Maybe they're better. And so what we did was have our variant expert, who is not me, look at those and say, here's why we think the variant approach is better. And ultimately we landed on variant. There's things about like the ways they do the dictionary encoding, or just their encodings in general are not as efficient, or there's certain ways, like the way the dictionary is set up, you can binary search it, which is really nice. Some of the ones we looked at weren't like that. So you have to scan the whole dictionary to find fields, whereas it's much more efficient if you can binary search, stuff like that. So we just kind of took a data-driven approach to, well, here's all these options, let's look at them, and did land back on variant. So that's where we've essentially settled with the community. I'm trying to think if there have been any other interesting questions around it. But the nice thing about it being an Apache project is you can go to the dev list and see the whole conversation there. So I linked at the beginning, and there's another link at the end to the actual conversation, or just go to the dev list and search for variant. It's not hard to find. All right, so I'm going to move forward. We're actually getting close to the end, even though we've only got we've only touched on encoding, because we haven't gotten so much to the metadata yet. I just wanted to touch on it briefly. Of roughly what it looks like is we're going to introduce this idea of subcolumn metadata. The subcolumns are those kind of nested fields within there. So if you've got a JSON thing that has an A with a B in it with a C, A.B.C would be a subcolumn, right? And there's that, the path there. There's kind of a definition for how you describe a path, which I've been saying, A.B.C. And what you end up with is kind of what you'd expect. It's just kind of a bag of stats for each of these subpaths. And what you do is you go through and you actually just calculate the stats as you would for any given file, but you're doing it at the subcolumn level and then storing that in there. So you got lower bounds and upper bounds and distincts and et cetera, et cetera. So this will be a follow-on proposal to Iceberg, and this will actually show up in the Iceberg metadata itself, the Iceberg spec itself. Then part 3 will be the materialization, or as they call it in Spark, which I actually kind of like the name, shredding. So this is where you say, okay, so the nice thing about this is there is a visual example here. So imagine you've got two rows where it's basically you've got an A that has a nested C and D in it, and you've got a B, right? And so in row 1, C and D are both value 1, and B is this string. And in row 2, you just have C, which is 3, D is empty, and B is a number. So if we were shredding this or subcolumnarizing it, the approach generally is you do an initial scan of the data, and you look for columns that show up frequently and generally show up with the same type. And I say generally because there's no, it's sort of up to the implementation to decide how they do this. Spark does it in some way. I think they actually don't even tell you necessarily how they do it in Spark or in Delta. Spark would be open source. We have a methodology for how we do it in Snowflake, but you can kind of make some trade-offs about how you want to approach it. But you kind of look and you say, well, what's likely to be commonly queried? What has lots of values, and which things are either totally consistently a given type or mostly a given type? And then what you do is you make a second pass through the data, and you basically, so I guess I have this written out, so maybe I should just follow the slides. So to give an example, A and C are ints for both rows, or A.C. A.B or A.D is an int or null for both rows. Effectively, we treat that as an int. It's empty, that's fine. Whereas B is a string and an int. So in this case, A.C and A.D are both good candidates for pulling out. Whereas A.B, not so much. And so then what you do is you go through and for those cases where you want to shred it out or subcolumnarize it out, you actually prepare a structured struct that captures that. So, an A that has a struct within it that has a C that is an integer and a D that's an integer. Then you're going to take a second scan through the data and pull all those values out into their separate subcolumn structs. So again, A and C would be 1 and 3, and for A.D, it would be 2 and null. And then as you're doing that, you actually remove or expunge those subcolumn paths from the variants for each row. So what you end up with then is the variant data, because you're going to still store any sort of the residual pieces that didn't get shredded out. Those end up looking like that. So you've got this root, A is empty for any, because the system would know that A.C and A.D were pulled out into the separate columns. But if it went, someone said A.E, they'd go back here and look and see, well, what's in here? And it's empty, it'd know that there was no A.E. And B, since B switched types, you would choose to just leave it in there and you'd have to go there to pull out A.B. I think in the Spark, the way Spark does it, they actually allow for, like they'll actually, say it's mostly ints for a column, but there's a few strings. They'll actually still subcolumnarize it or shred it out in that case. All the ints would go into the subcolumn, but there's also, they actually kind of treat it as like a union value where you can have this untyped thing that if you don't see a typed value in there, you look to see if there's an untyped value and it may be a string or some other type. So anyway, so for this, there's going to be some metadata around this as well that will go into Iceberg because you kind of have to describe, how, what are the paths, what are the paths that you are subcolumnarizing, and you need a way to say which paths have been pulled out into separate columns and which ones don't. So that portion will go into the metadata. A lot of the work then really on subcolumnarization is on the engine side, particularly on the writing side, but on the reading side as well, just being able to know, okay, I'm looking for some subpath within this variant, but I need to know, do I look into the untyped kind of variant section of it, or do I go to one of the materialized subcolumns? So this will be part 3. That will also go to the out as a proposal relatively soon. And I think that's it. So yeah, if you have any opinions or any interest in jumping in, please do. This is the link to the thread, or just search on the dev list. And also we're hiring. So if you want to come work on this or other stuff, we're building up an open source team who is focusing on Iceberg and Polaris once Polaris goes out to open source. And we also have a lot of non-open source stuff in the same area, doing lots of cool things. So thank you all very much for coming. And do I have time for questions, or are we popping over to the other one?
We have room. We have time for maybe like 3 minutes of questions since we started a little late.
Sounds good. Anybody want to fill up 3 minutes of questions?
In the proposal, there's a conversation about exposing JSON as a type.
Yes.
I want to know, like, what are your thoughts on that, especially standard?
So for context, for people who can't hear without the mic, one of the discussions that's been happening in Iceberg is around whether we expose the full variant type, which has all those types in it, or there are a number of engines that are Iceberg compatible that are basically only JSON, only speak JSON. And so the question is there value? The question brought to the list was, is there value? Like some people propose we should only do JSON. Others have said, should we do both JSON, JSON and variant? JSON is basically a strict subset of variant. It's like variant with strings and some sort of numeric kind of type. I think where we're heading, so Snowflake has both. Snowflake does have a specific JSON type because it's convenient to have something. We had so many people using JSON as an input format that is just, it worked out nicely to have that, and like they can kind of understand the constraints. I think the arguments being made by Ryan and others in the Iceberg community is that there's just not that much, like there's not much value in constraining what you can do on the write side. And on the read side, as long as we have a way of defining how you coerce, like it's just a few types like timestamp, UUID, that you can't really bidirectionally go into JSON and back out. Like it's pretty easy to say, well, how would you coerce a timestamp into something you could have in JSON? Well, there's the IEEE whatever format, you can turn it into that. So I think where we're headed most likely is we will just do full variant. We will also define if you're converting it to JSON, this is how you should convert it. And then if you're going to go from JSON back to variant, just don't do that. If you have an actual variant column and you're going to do a read, modify, write, don't do that unless you know that the variant only has JSON data. That's a bad idea. You're going to have a bad day. I think that's where we're headed. Yes.
pathway of threading, which is Spark. They also pull out the data of different type and do a separate file because it's like and your information. You only pull out the same and do the type that's data with different type. But kind of want to ask about
I guess, so I'm not a variant expert, particularly Snowflake's implementation, so I may even be giving you false information. We may actually support that. I think what it is, there's the way that Spark approaches it, I think is a little more flexible than ours. I wish Selchuk was here because he could give you sort of the subtleties around it. But I would say, you know, what our variant was like 5 years old, 7 years, I don't know. Variant came in Snowflake a long time ago. They made some design decisions at that time, and that's how they went with it. And I think, you know, Spark implemented theirs recently and made different design decisions. I think that's really what it was. It's sort of trade-offs in the design space. And we went one way, they went another way. You know, sorry, I don't have enough, I don't have enough expertise here to give you anything more nuanced than that.
All right, I think that's all the time that we have for questions. Let's thank the speaker again. Thank you.
All right, thank you all.